All right. So we left off kind of talking about the demand equation. I said today we're gonna do a little bit on supply, maybe get to equilibrium. We don't equilibrium today. On Friday. Oh, I think I've got the equilibriums working for everyone today, so we should be good with that. Not something off the bat, but kind of maybe later on today. So we started talking about demand, and wasn't really satisfied. I wanted to kind of hopefully get you to think about it in slightly different way. So let's say that we go back and we use my kind of example of, I guess, the drinking beer. I don't remember what values I used before, but we'll do kind of this is how much I benefit from drinking each beer, right? Or kind of how much I would be willing to pay, right? And the reason why we kind of say willing to pay is we know that someone will choose to purchase something or choose to make a decision to do something as long as the marginal benefit is greater than the marginal cost. But here, thinking about what's the marginal cost of purchasing these beers, well, it's the price of the beer, right? And each beer is going to have kind of the same price. And so this is another way of thinking about how we build that demand curve. Okay? So what ends up being true, like let's say got my quantity of beer down here. I've kind of got the price up here in my y-axis. So you guys can see it over there. All I did was put price in the y-axis, quantity of beer down there in the x-axis. So let's say the price is $11. How many beers will I purchase? None, right? Why? Because for all of them, how much I'll benefit from consuming the first, second, third, and fourth are all less than that price of $11. So we know 0, right? And then you can kind of think about, we could break this down to increments, like we could lower the price by a penny. I would still buy 0, right? $10.99 is still greater than all these. And really the first kind of price where we would see anything purchased would be at that price of $10. We said someone will choose to do or buy something when that marginal benefit is greater than or equal to that marginal cost, which in this case is just the price. So there's where we saw the quantity of 1, right? As soon as that price gets to $10, we'll see the first unit sold. And then from there, well, what if I put the price at $9? Well, I still keep selling that same 1 unit, right? And it's not until I get down to a price of 8 that I would then actually see the person decide to buy the second unit here. So in practice, our demand curves are probably going to kind of look like these stair steps. If I'm thinking about, I can't have like half a beer, right? Now, if I could purchase half a beer, well, then all the values in between become possible, and that's where we get kind of that nice linear demand curve. But really, you know, it doesn't matter kind of whether or not we're going to see this discrete choice. It just makes the math a little bit harder, which is why for this class I said I'll keep everything linear. Nice kind of continuous linear lines. We're going to assume that we can always buy fractions of quantities. Now I know, like in terms of how we think, that doesn't make sense. I can't get 0.23 of a beer, right? No one's going to sell me just 0.23 of a beer. But the idea is that when we're looking at the economy as a whole, I mean, these units become, even if they're just like discrete, like there's jumps from 1 to 2, it might as well be continuous, right? We can kind of really come up with any kind of a purchase order, any combination of units. Right? But I wanted to just kind of think about it this way, in that really where those points in the demand curve are coming up, right? How we're coming up with those, what's the prices at which we'll see the price fall, you know, below or equal to that person's marginal benefit. So that's why we said another way of thinking about these demand curves, we can kind of think about them as representing the marginal benefit, right? I don't know, just another way of talking about it. I always try to give, you know, several different ways. Sometimes one will click with someone and the other way I describe it will click with someone else. So it's just another way to think about the demand curve and why we can interpret it as really representing the marginal benefit for each one of these different quantities. Because we know that when someone decides to purchase that number, that quantity, that's because the price has now fallen to be below or equal to whatever their marginal benefit is. So the first price where they'll buy the second unit will be their marginal benefit from consuming that second. And we talked about some other features, right? Downward sloping as the price goes up, people buy less of a good. And we kind of talked about a little more of the kind of calculating slope thing. Does anyone remember? So how did I relate this? When we're working through like the gains from trade and the production possibilities curve, we said when I was calculating the cost of the x-axis good, I always looked at the slope, right? So here when I'm looking at demand, what's my x-axis good? Well, the quantity of beer or whatever good I'm looking at. But it's in terms of the y good. Well, now my y-axis is just the price or dollars. So just like with the production possibilities curve, the slope of my demand curve tells me the cost of one more unit of my x-axis good. Okay. So over there, whatever the slope of that line ends up being, that will be the price of one more beer, right? One more unit of that x-axis good. A little bit of like a summary, kind of where we left off before we kind of go a little bit further. So we left off this individual's demand curve. It's kind of easy to think about because like we're individuals, we buy things, right? So it gets a little bit more. Oh. So one thing I then kind of alluded to is if we want to calculate the marginal benefit of these different quantities, right? So let's say I had, I don't remember the numbers here. So let's see if I think it's this. So I had kind of my demand curve equation. And I said, well, really all this is just like you would see in a math class, right? We kind of call this, you've got an intercept value, you've got a slope, and it's just a y and an x variable. So when I graph this out, this demand curve was really just coming from my intercept was 6, the slope was 1/2, right? I said I could figure out where the demand curve hits this x-axis. How could I do that? So this is going to be the quantity demanded when the price is 0. So how could I figure out what that quantity would be? So if the price was 0, how can I figure out what the quantity would have to be? Well, I could just plug in a price of 0 and then a little bit of algebra to solve this equation. Okay? So if I have that, right, 0 is equal to 6 minus 1/2 times the quantity of x. I'm just going to move this to the other side. 1/2 quantity of x plus or minus 0. I mean, I can really ignore that, right? Adding or subtracting 0 doesn't change anything. And so I'd be left with, right, adding 1/2 qx to both sides. I could then divide by 1/2, that would cancel. Divide this by 1/2 or 0.5, and I get the quantity of x. What? 12. Okay. So really when I'm thinking about finding different points in this demand curve, I could just plug in, if I want to know the quantity demanded when the price is 3, I plug in the price of 3 and then just use a little bit of algebra to solve for that thing that I'm interested in, which is what quantity, so for the question mark, right? What quantity would result, or what will be the resulting quantity if I saw the price be $3? But I can also work the other direction. We said that the price, right, at which I'll see the second unit purchase was really also just telling me, well, that was the person's marginal benefit for that second unit, right? They'd be willing to pay up to that price if the marginal benefit was exactly equal to that value. So if instead I wanted to say, okay, what's the marginal benefit of that fourth unit? Well, this price really is reflecting also the marginal benefit. So I can also think about the demand curve where that y-axis variable is not just telling me the price, but it's telling me the person's marginal benefit, their ability and their willingness to pay. So if I want to know what's the marginal benefit in terms of dollars, right? So if I think about, I said that this was price, but we're really thinking about that's measured as the, the dollar value. If I want to know the marginal benefit of that fourth unit, all I do is plug in what quantity I'm interested in finding the marginal benefit of, right? So I plug a 4 in here. 4 times 1/2 is 2. 6 minus 2 is, what did I do? Oh, because I was drawing this out of scale. So this should actually be right here. So I plug 4 in there, I get that marginal benefit. Right. So all I do to find the marginal benefit or where I'd be at on the demand curve for that fourth unit is plug that fourth unit into that quantity and then solve for what that price or what that marginal benefit would be for that fourth unit. Okay. So it's really, you can work in either direction, right? You can find what quantity will be purchased at given prices. That was just plugging price in and then solving for that quantity. Or you could find the price that would result in, or what the marginal benefit of different quantities were. What there, I'm just plugging the quantity in, and there it's not as much algebra, right? It's actually a little bit easier to work in that direction. I don't have to kind of move things to other sides and then do a little more algebra. Okay. Any questions over anything? A little bit less like economical as opposed to kind of more graphing and kind of equations. Yeah.
Can you? I'm sorry.
No, I'm fine.
Where you got the 6 minus 1/2?
Oh, I just, so that's a good question. All right, here. Let me get this out so I can go back. That was just the example problem that I came up with, right? So you would have to be told what the demand curve was, like what the demand equation was. And then from there, you could determine the marginal benefit of different quantities, or you could determine what quantities would be demanded at different prices. Yeah, so that equation just came from the previous slide. That's the example we left off on. This could be 100 minus 5qx, right? Depending on the example we're looking at, but you have to be given, excuse me, what that demand equation was. Any questions for you? So we've got our individual demand curve. I had this example from last class, but I think this is where the equation came from. We're kind of thinking about these orange mocha frappuccino that Zoolander was ordering. We have this individual demand curve. We can kind of think about it as I consume each additional drink, that marginal benefit or my willingness to pay, the price I'd be willing to pay, will decline, right? And that's kind of what I was trying to build up here with returning to that theory example and start off class, right? As I purchase more, as that quantity goes up, the marginal benefit of each additional unit is falling. Okay. So how do we move then from understanding individual demand to understanding the demand for this product in the entire economy or the entire market? So when we move from kind of looking at the individual to the economy as a whole, we would call that not individual demand curves, but the market demand curve, or the market demand schedule if we had a table. Okay? So all we're going to do is essentially at every single price that we were thinking about before, we're now not just going to see, well, how many would Zoolander buy, but we're also going to say, take how many you would buy and add to it how many this other person in the economy would buy as well. So we'll assume now that we have a 2-person economy, right? So when we're calculating the market demand, we have to add up the quantity demand from each individual at all these different prices. So I think it shows Ken here. I can't remember if he was the one that died in the tragic gasoline fight or not, but we'll kind of use him as the example, right? So we have the old kind of demand curve for Zoolander, all these different prices, the quantities that we decide to purchase at each one of these prices. We got Ken's demand. Maybe Ken's demand is, and we can kind of see here as the price declines, his demand doesn't fall kind of quite as quickly, right? So it might have a kind of a flatter slope demand curve. We could draw both these individual demand curves out if we wanted to, but generally what we're more concerned with, if I'm the company that's making these drinks, is how many is going to be demanded overall, right, in the economy. So what we'll do is at each one of these prices, just add up, well, the price of 6, I'll sell 0 to Zoolander, 5 to 10, So the market quantity demanded would be, oh, I'm working the opposite way, sorry, at a price of 0, they both consume 12, right? So we would see on the market, we would sell 24 of these drinks if we priced it at $0. If I then increase the price, because I can't stay in business long if I'm charging nothing, right? I increase the price to $1, Zoolander buys only 10 and buys 11, market demand is now 21. This isn't terribly complicated, I don't think. We would just kind of add up the quantity demand of every person in our economy, at a simple 2-person economy at this point. And we could come up with these values all the way down to kind of this last price of $6. Right? And we could kind of keep going if we wanted to. What do I know is going to be true though if I charge the price of $7? What's the quantity demand for Zoolander in these years? 0, right? He's not going to buy, he's not going to buy any at 6, not going to buy any at 7. You can't negatively purchase an item, like you just don't purchase it, right? So from every point or every price past $6, we know individual demand from Zoolander is 0, and that trend is still going to continue to decline, right? So we're still going to see this decreasing demand curve, right? But maybe it decreases quicker or slower at different points, depending on if we have people just stop buying it altogether. But we could graph this out, right? We now have the different prices. So we've got our y-axis values. We've got our different quantity demanded for this good. Well, now it's not individual demand, it's the market demand, but it's still kind of our point on the x-axis. So we could go through, create a market demand schedule. I've got my, 7 different prices, 7 different quantity demanded. I can just plot those points on a graph, right? Draw a line between them and kind of think about, I don't have to just change the price by $1. I could change it by 50 cents, 20 cents, whatever I want. And so we can have this nice continuous linear demand curve. I think that's too crazy. All we're doing is adding up every individual's demand at every single price to come up with market demand. So another way of thinking about this, I don't think I have a visual, so I'll do this here. Let's say we're thinking about like the US economy. Right? We typically don't draw the visual of this, so it's going to be a little bit weird. But let's say use anything. Think about the units of gas, right? Gallons of gas that are going to be purchased, right? And we think about a bunch of different prices. And I don't know. I've got a Volkswagen diesel right now, so gas is probably going to be on my mind because the diesel just won't fall in price. But you can think about it as like, let's say $6 or something like that. You can kind of think about it as maybe at $6, I just refuse to drive when I start walking campus every day. But then as the price falls, I'm like, oh, I'll get a little bit, like I'll walk to campus, but I still need to drive to the grocery store. I don't want to walk that far, things like that, right? And so maybe this is my individual demand curve, all right? Maybe there's someone who doesn't, I don't know, college student, perhaps one of you, on a pretty fixed income. Maybe you're like, hell, I'm not paying more than $3 for a gallon of gas, right? And so then if the price falls below 3, maybe then I'll start to buy some, but anything above 3 or 1. So we've got 2 individual demand curves, right? So to get my market demand, I basically at every price would just take the quantities of each individual's demand curve, right? We have 2 individuals, and I would add them up. So you can imagine my individual demand curves, if I add them up, my market demand will always be like greater than those, right? But then I have another person in my economy, and another person in my economy, and another person, so really to get market demand in practice, what we would do is take the quantity this person would buy at this price, quantity this person buys at this price, the quantity this person buys, this person, add all those up, and then graph that point out here. And then we do that at every single price. So you can imagine, like, in a real economy, this becomes a lot of work, right? First of all, it's hard to get information just on every individual's demand curve. So you're kind of looking at purchase history, and well, I've got 100 different people I can follow, and I can see how much they buy of the good, and I know that there's X number of people in the United States, so I can kind of take how much So 100 people would buy, multiply that by how many times 100 goes into the population of the US, and come up with some idea of what market demand is, right? But I would still need to, from those 100 people, understand what their individual demand curves are, and then to kind of add them up to figure out what market demand is. So we're not going to be like doing this in practice in this class. You know, maybe I give you a 2 or 3 person economy and ask you to calculate market demand. That's very doable. In practice, we can't do this by hand. We're going to have to use computer programs, right? We're going to have representative demand curves. We can have a computer do it for us very quick. I'm not going to be able to do this, like sit down by hand and really do this. But the idea is still the same, right? The computer would still be doing what you do by hand. You just can't add up the individual demand curves of gas for however many people are driving in the US. Right? So that's the idea behind market demand. Once we understand that, right, the next thing that we're going to go into is, okay, so we've got all these prices. I, as a company, can look at this and say, okay, if I set prices at these different levels, I know how much is going to be demanded on the market. Right? If the price for a gallon of gas is $10, there are no market demand is 0. But if it falls to 5, then market demand is 100,000 gallons or something like that. So I've got this demand curve, and it's telling me the relationship between the price of the good and how much of that good is purchased. That's what the demand curve is telling me. The relationship between the price of that good and the quantity that's purchased of that good. But there are outside factors other than the price of the good that might shift that demand curve. So if you go back, I don't know, 30 years ago for sure, there's no electric cars that are really realistic option for someone to buy, right? So there probably existed a relationship between the price of gas and how much was purchased back then, right? So maybe we had kind of this nice slope. Give you an idea of what we're thinking about when we think about shifts in demand. Okay? So we go back 30 years ago. All this, the quantity of gas, which is not in gallons, about price, dollars. So maybe, I don't know, something, demand looks something like this. We'll call this 1990, right? The demand in 1990 tells us the relationship in 1990 between how much gas is going to be purchased and the different prices. Right? So now, 30 years later, right, we have this substitute, right? I no longer have to have an automobile that requires gas, right? Maybe I have a purely electric car. Right? So what do you think probably happened at any price? So even if the price, let's say in 1990, if we set the price at, I don't know, $2, and I don't even know what realistic values would be here, but we'll just kind of come up with something that makes somewhat sense, right? So maybe at a price of $2 in whatever economy I'm looking at, maybe it wasn't the US as a whole, maybe it was one state, one county. I don't know exactly how many gallons of gas are consumed every day, right? Let's say that at price of $2, we see that whatever market we're looking at, whether it's the US as a whole or one individual state, that 100,000 gallons would be purchased. 30 years later, so the demand curve in 2020, right? What do you think is probably true about the amount of gas purchased if gas is still $2? So the price hasn't changed, but there's now these outside options. You no longer have to have a gas that requires, or not gas that requires, an automobile that requires gas. You can now get a purely electric vehicle. What do you think is probably happened to the amount of gas that's consumed? The price hasn't changed if it's good at all, but some outside factor did. Probably fewer people are even having cars that require gas. And so when we think about it, we can see things that at any given price, even if the price remained at $2, the amount of gas now might only be, I don't know, probably exaggerating, but half as much, right? And then it doesn't matter what price I set, this new demand curve, if I'm looking at any price, the quantity demanded in, let me write this down first. 2020, the quantity demanded is always going to be less than what it would have been in 1990 because this outside factor changed. Even if the price of gas didn't change at all between those two time periods, this other factor has changed, which is people now can drive electric automobiles and no longer require gas. So that's just a stupid kind of example, I guess, or just kind of an introductory example of things that can change that might shift the overall demand curve. And you can think about why. How are we coming up with market demand? We were looking at every single price and we were adding up each individual's quantity demanded, right? So what happens when I now have electric cars? Some of these individual demand curves go away, right? This person bought an electric car. This person bought an electric car. This person bought an electric car. Now, when I add up the quantity demanded, there's fewer individuals who are even purchasing gas, right? So that's just one way of thinking about kind of what could cause. And so now my market demand curve, I didn't bring my marker over here, but you can imagine now when I add these values up, market demand won't be quite as high. So that's the idea behind why we could see shifts in the entire demand curve. Even if the price of the goods stay the same, it's just that there's an outside factor that changed. Okay. So the way we think about the demand curve is the relationship between price and the amount purchased or quantity demanded of that good, holding everything else constant, or all other things being equal. There's different ways of saying this. I typically say holding everything else constant, but other things being equal is another way of saying that, right? Other factors have remained unchanged. So what happens if these other things change? I kind of already alluded to this, right? We can see a decrease in demand. So when we see lower demand, right, that means that at any given price, quantity demanded goes down, right? So it's going to be kind of this like left shift in demand. If I want to see an increase in demand, so maybe let's say before the end of this year, some new technology is found and you can drive 1,000,000 miles on 1 gallon of gas. What do you think happens to the overall demand for gas? Probably goes up. I mean, right? And in the sense of like, we'll have more people buying gasoline powered automobiles. And actually, maybe that I can't do 1,000,000, right? Because then you just don't need any gas to get anywhere. But you can imagine like a technology comes out and it makes gas powered automobiles a little bit more effective or efficient, right? So maybe there at the same price, well, now a gallon of gas, right? $2, like there's a lot more people willing to buy, right? Because it can get them a lot further. And so maybe if we had some type of technology improvement like that, we see it at the same price, quantity demanded might now be much, much higher, right? So increases in demand, if these other factors change, even if we kept price the same, right? We might see that quantity demanded goes up, and it doesn't matter what price we look at, right? If the price was $3, quantity demanded before was here, now it's all the way out here, right? So we can kind of think about the entire demand curve has shifted because of this outside factor changing. That would look something like that, right? This rightward shift. So a rightward or upward shift in demand is an increase. A leftward or a downward shift in demand is like a decrease. Okay. Another way I was thinking about this is your decrease in demand is if your demand curve is getting closer to this 0, point, right? Getting closer to 0, it's decreasing. An increase in demand is you're moving further from that 0, point, right? Any questions on that before we keep moving here? If there's anything else I want to say before we go into actual like examples here. I think we're set up. So let's start to think about what some of these outside factors that could change are. And we have a short list of potential like areas that could change demand. There's many, like we could like break it down and be a lot, like create a lot more categories. We're going to have like 5 or 6 major categories. Okay. So the first one is just the number of buyers. I've kind of already alluded to this, right? If we're calculating market demand by adding up individual demand curves, well, what happens if my population grows? I now have more individual demand curves. So when I add up all those values, my market demand will be higher, right? So as I add more buyers, generally when I say more buyers, I always think about this because it's easier. The population goes up. I have population in an area goes up. We're going to have more consumers of these goods. And so I would see an increase in demand. Right? So I've got more buyers at any given price. There's just more individual demand curves now. So when I add them all up, I'm going to get a higher overall demand curve, right? Or an increase in demand. So like when we added 10, right? We added one more buyer. We went from having just Zoolander's individual demand curve, which would have represented the entire market when we only had one person. When we added that second person, the demand increase. So another thing I want to think about here. We could add so we could add another person, right? Han's so hot right now. We add him in. Also, if you haven't seen Zoolander, these references are probably just going over your head. But if you add a third person, well, now market demand is even higher. Right? Now, what's an issue as of recently, and we think about the United States, this is kind of going a little bit further, maybe just to pique your interest if you want to continue to take econ courses or you just have general questions. So right now, I think it's still above 2, but it's close to falling below 2, the birth rate, which means that if the birth rate average is less than 2, that on average, right, we're having fewer than 2 people be born for every 2 people that are having a kid. So what would happen to population? Start to fall, right? We're not replacing all of the citizens that we have, right? So if birth rates continue to decline, eventually, if it falls below 2, we potentially could see this decrease in population. So what happens to market demand for most goods? If I'm a company, I really don't want this to happen, right? Because as population starts to decline, my market demand for my product also declines, right? Because I just have fewer people in that economy, right? So if I'm thinking about maybe where would be a good place to start a business, where could I see demand for products really increase, really shift to the right or up? I might want to target countries that have really high birth rates, right? I know I've got an expanding population. Why the Chinese market is very attractive to a lot of companies. The Indian market right now is very attractive because you have this huge population growth. Where if I'm starting a company today and I'm really interested in the future, the United States, depending on what I'm selling, right, probably isn't exactly my most desired location, right? But this also assumes that my company is fairly global across the world. But just kind of thinking broader about these things. Okay?
Is that why they are trying to get rid of birth control?
Well, that goes further. That's more of I go further than what I would have any information on. But if I'm concerned about the population growth of my economy, yeah, I might take, maybe I think what would be more likely is they create incentives for you to have kids, like there's tax credits, right? The reason why they do that, well, they want to help families out that have kids, but also like they want to incentivize you to just have children because they do want the population to grow. A little bit conspiratorial, but I don't think I don't think is far-fetched at all. There's a reason why they create those tax incentives.
Yeah, it could be conspiratorial, but I feel like it's logical too.
Yeah, well, I mean, now you're getting me on the side. So, but anything that's conspiratorial usually has some kernel of truth. Whether or not the dots are actually connected takes a little more investigation. But at least you're starting to think about incentives that could exist for the government or who else, right? And that's really what a lot of the class would be. Identifying incentives, identifying disincentives. All right, so back to demand, right? So we got the number of buyers, right? That kind of makes sense. I don't think we have to get too crazy here, right? We think about as I add more and more people at any given price, I'm going to see that I have a higher quantity demanded. I'm going to see this shift to the right, or this upward shift, depending on how you kind of think about it visually in my demand curve. So income is another real interesting one. So let's think about how might income influence demand. So if I've got more income, let's say I start out and I've got, doesn't even matter if it's good for right now. Let's just think about, here's my starting demand for some product. Okay? Let's call it, let's think about maybe automobiles, cars, right? At different prices, how many cars will be demanded on the market, right? This is my market demand. If I then see that the income in the US overall, right, increases so that people on average have more money, what might I expect to happen to the number of cars I see purchased in the economy? So if people on average have more money, if you don't want to think about automobiles, you even think about this as, oh, I don't know, sporting event tickets, right? If people have all this, income increases of, like every single person has 100,000 extra dollars, what do you think is going to happen to the quantity of tickets that these sports teams sell? It's going to go up, right? Most goods we think about, even if we kept the price the same, and usually I'll use kind of this little like asterisk to denote this is the new demand curve, right? After we saw this higher income, new demand is going to be higher, right? People have more money, they can buy more of the goods, right? So this is what we'll call kind of normal goods, right? This is, I think, how we think about most things. If I have more money, I buy more of it. Good question. Okay. So this is like a typical good. But there's also goods in which if I have more money, or if everybody has more money, maybe I actually see demand. And I'll kind of do two asterisks here, right? Maybe I see demand decrease. So what are some examples of goods like this, right? Let's think about, I always use ramen noodles. It's a really easy one. I also use like Natty Light. I have not bought Natty Light since I was 22. So I have more money. I am going to buy less of these maybe inferior goods. So we call this inferior goods, right? They're not as high quality. Generally, people with lower incomes are purchasing these. So if everybody has more money, nobody's going to want to buy Natty Light, right? Or nobody's going to want to buy as much ramen. Well, I might still like ramen, but I'm not going to buy like the 25-cent packs or whatever the cost is now, right? So for these inferior goods, the demand shifts from having more income will go the exact opposite direction. So normal goods, the direction that my income goes is the same direction demand goes, right? Income increases. For a normal good, I would see demand increases. If I had less income, income decreases. For a normal good, I would buy less. I would have demand increase. But for an inferior good, it works in exactly the opposite direction. If I have income increases, and I'm thinking about inferior goods like Natty Light, ramen noodles, people buy less of them. So their income increases, decreases demand, and vice versa. Another one I always use is when we're thinking about like automobiles or new cars. Public transportation is another really good example of an inferior good. If I start to amass more and more money, and this isn't like even, I mean, if you think about that, so like we're in Muncie, right? But if you live in like New York City, it is very expensive to own a car because you got to pay for a place to park. Parking is hard to come by, right? And so there's a lot of people who use public transportation. And you have to amass pretty significant amount of income to then transition from not using public transportation to owning your own automobile in this place like New York City. So this isn't, and I think it maybe sounds trivial, but like in larger cities, this is a very good example of kind of this inferior normal good. So get to pay a lot of paycheck no longer drinking Natty Ice, right? So this is the idea of income. We have two different types of goods. We then have related goods. So I kind of alluded to this a little bit earlier when we were talking about electric versus gas cars. We'll dive into a little bit deeper here. So if I have substitute goods, these are goods that can be used in replace of each other. So my electric car versus gas powered car example would be a good example of substitute goods, right? I could, instead of buying a gas powered car, buy an electric powered car. So if the price of electric cars starts to fall dramatically, so the price of electric cars goes down, what do you think happens to, even if the price remains the same for gas powered cars, what do you think happens to the demand for gas powered cars? Goes up, right? So I saw someone pointing out, right? Because if the substitute good is now cheaper, right? The prices went down. I'm more likely now to buy an electric car than I would to buy a gas powered car the next time I go to buy it. So substitute goods, and I said it in the opposite order, but if a substitute good has a price increase, so let's say for whatever reason, some new regulations exist and they throw a bunch of regulations on electric cars and all of a sudden the price goes way up, right? Or maybe one of the materials they need for the batteries is much more expensive due to something, you know, happening globally. You see the price of electric cars go way up. What's going to happen in demand for gas-powered cars? It's going to go up, right? Because the substitute is now more expensive. So I'm more likely not to buy that stuff. So for substitute goods, the price of the substitute good and the demand for the good you're interested in move in the same direction. Okay. What about do I have examples here? Okay, so another way to think about this is if you have like two very similar goods that are substitutes, there's just difference in branding. So Pepsi Coke is a good way to think about this. If you go to the store and Pepsi is $4 for a 2 liter and Coke is $1, I don't care how strong your preference for Pepsi is. I mean, unless you have an unlimited amount of money, like most of us are going to choose one at $1 for 2 liters as opposed to $4, right? So, and everyone's gonna be different, but the idea is there, as the price continues to fall lower and lower for that substitute good, you're more likely to substitute over. Maybe not everybody does. Maybe there's some like diehard Pepsi people who like the marginal benefit from Coke is always zero for them, so they're always gonna buy Pepsi. But there are gonna be some people, like some individuals, that will then substitute over to buying Coke. You lose them from the overall market demand curve with Pepsi. That's the idea behind kind of substitute goods. Another example, laptop, desktop computers, it's kind of irrelevant now, like they're both so cheap. Pens and pencils. I guess if you're really deciding between the two, right, you don't have enough money to get both, right, you would kind of be looking at the price there, and whichever, you know, the price of one of those changes, you might be more likely to substitute over to buying them. So complementary goods are going to be goods that not are used in replacement of each other, but goods that have to be used simultaneously. Might be a good way to think about it, right? Or in conjunction, used together. So I'll start out with an example I think I can't poke holes in, and then I'll start out with some more that maybe you could argue for some people they aren't complementary. So electric cars, and then kind of the battery that comes in them, right? Those batteries, if they become more expensive, right? And I can't use my electric car without that battery, what do you think is going to happen to the overall demand for electric cars? Goes down, right? Because I have to use these together. Another way of thinking about it is, well, to use my electric car, the price is really how much did I pay for the electric car, but also how much I'm going to have to pay for the battery or to replace the battery. Right? So if these batteries are very, very expensive to replace, complementary goods, we might see that the overall demand for electric cars fall. So what has happened historically over time? Guess what's happened to the price of those batteries to replace them? It's gone down. So what's happened to the overall demand or amount of cars, electric cars we see purchased? It's gone up, right? Because we have to have that battery in order to use the electric car. They're complementary goods. When the price of that complementary good, the battery goes down, overall demand for electric cars goes up. Now, the other one you could use, this, but the age-old example is like peanut butter and jelly, right? Gasoline and like SUVs that get like 5 miles a gallon. You can kind of think about there. Well, there the price of the substitute, or sorry, the complementary good really influences whether or not I decide to buy a Hummer versus a Toyota Corolla, right? In fact, if you look, you can go out and grab data, and when you look at the price of gasoline, it's almost perfectly correlated with the decision to purchase lower mile per gallon vehicles, right? So when gas prices are high, people are less likely to buy SUVs, more likely to buy compact cars, and vice versa, right? So it kind of makes sense. I don't know, bagels and cream cheese. I don't ever eat bagels and cream cheese, like, so that's one where I can poke a hole in that because I could eat a bagel without cream cheese or cream cheese without a bagel. But the idea is two goods that you would have to use together, which is why I always like the gasoline kind of, you know, car example, or anything that requires a battery, right? Anything that requires a battery, that battery and that good are complementary goods, right? So if the price of batteries, you know, to use my clicker here, all of a sudden AA batteries are like $100 for 2 of them. I'm not going to be using this anymore. I'm not going to purchase this. My demand for this good is going to go down, right? So I think batteries and things that use batteries is always a good example to think about when it comes to complementary goods. Okay. All right. I think we've got enough time. We've got a couple minutes left. We'll try to go through this. And I might revisit at the beginning of next class. So the other thing, we've already talked about income, right? We can kind of also think about future expectations of prices and income. So if I think that my income is going to be higher in the future, right? What might I do if I'm thinking about normal goods? Right? If I think my income is going to be higher in the future, what might happen to demand for normal goods? Right? Well, if I expect to have more money tomorrow, I might be more likely to buy goods today because I know I'm going to have that money coming in the future. Okay? So it kind of works the exact same direction as the income effects. Whether or not I have more income or I expect to have more income, demand will increase in both cases. All right, so that one's and vice versa. Right? If I expect less income in the future, I may be less likely to purchase goods today. And then the same holds true for the inferior good. If I have an inferior good and I expect to have more money in the future, maybe I'm less likely to buy those ramen noodles and the natty like that. So that one's not kind of crazy, too crazy from what we talked about before. It really works the same exact way as having actual income. Income expectations works the exact same. So the more difficult one might be pricing expectations. So what happens if I think the price is going to go up for something I want to buy tomorrow? So let's say my gas tank's getting pretty low. And someone tells me, hey, gas prices are going up $1 overnight. So I expect prices to be higher tomorrow. What might I do today? Go out and fill my tank, right? So my demand today currently might go way up if I think prices are going to be higher in the future. Right? Also, it works at the exact so if I've got higher expected prices, current demand will go up. What if I expect the price of gas to fall by $1 overnight? Well, as long as I got enough gas to get to the gas station, right, in the morning, if I expect lower prices tomorrow, what's going to happen to current demand? It's going to go down. I'm going to want to wait and buy it tomorrow. So, whoops, sorry. So we have kind of higher expected prices lead to higher current demand, but you can also do the flip side of that. I expect prices to be lower in the future. I might also expect to see lower current demand. And then I've got a catch-all category. I'll start back up on this to kind of finish it. It's just taste and preferences. So we'll kind of cover this on the beginning class on Friday. We'll jump into supply. We'll talk about how we think about the supply curve, things that would shift supply, and then I'll probably just start to introduce the idea of equilibrium at the end of the class. Okay? So I highly recommend start working on that homework assignment. We've now worked through the vast majority of the demand questions. You can go on and get through all the way up to that point, and then we'll finish up with supply and equilibrium Friday and next week. Okay. All right. We'll see you guys on Friday.